Welcome back to P-Rust Coding. This is the AI networking class, and we're going to continue with the introduction to AI networking. Today, we'll be going over the key benefits of AI networking. I have a sample code that I'd like to show you guys, so let's get started. As you see on my screen, if you saw the MiniNet installation, this is the VM. So I'm going to go ahead and log into my terminal, get my terminal window up. We're just going to show you my Python version. All right, we're running 3.8.10 on this particular VM. I'm going to show you the distribution again for this particular VM. It's an Ubuntu 20.04.6. All right, so let's go ahead and clear that. So let's go ahead and get started. We're going to change directories into the introduction, and then we're going to create a new directory. We're going to call this key benefits AI networking. Awesome. We're going to change to this directory. Awesome, and clear this. Awesome. And then we're going to create a file so we can work with it. Call it example.py. All right. If you notice in my Explorer, you should see the example.py. So we're going to get rid of the tutorial, the terminal, and then we're going to start our coding. So we're going to work with about 4 or 5 packages. So the first one is the NumPy, which we discussed in our introduction. We're also going to bring in our ski learning AI, our machine learning model. We're going to use the linear regression. We're also going to pull in a time so we can leverage to simulate some gaps between stating our data with this example code. And we're also, instead of, I'm started working on using logging instead of printing. So we're also going to be using the logging package as well. So let's go ahead and get started. So we're going to import our NumPy as NP. We're going to import time. We're going to import our logging. And then last, we're going to bring in our machine learning model. Import line regression. Awesome. Now, since we got that, so with the logging, we want to go ahead and set up our basic config for this. So we want to go ahead and create logging basic config, and then here we want to format it because we want everything to format correctly. So we want a certain format for our output. Here we're going to specify a percentage sign. We're going to put the level name, put an S right there. We're also going to put, so that's going to be a colon. We're going to put the message. So we're going to bring in the message. And then we also, so that should be enough. And then we want to specify what we want to output. So we're going to put the level, and we're going to put logging.debug. Awesome. All right, so now that's set. Let's go ahead and get started. So first thing we're going to do is we're going to create a timestamp. This is a list of time stamps that we're going to specify. So we do the timestamp. So this will be an empty array. Timestamp equals. The next one, we're going to do the same thing for the traffic flow. So the traffic, we're going to capture the capture data. This is also going to be an empty array. Next, we're going to create a for loop to create both the timestamp, and we're also going to create the data. the traffic data array. So we're going to do for I in range, and we're going to simulate a 24-hour period of a day. We do a timestamp, and then we're going to append, and then we're going to add in the index. All right. And now we're going to do an if statement. So I'm going to say if I, and we're going to specify this is, we're going to allocate the busy hour or high traffic hour or the high peak hours. So we're going to specify between 8 a.m. in the morning, and we're going to say to 6 p.m. in the afternoon. Those are going to be our peak hours. All right, so then we're going to say traffic data dot append, and then in this we're going to use the NumPy. So we're going to use the random package method, and we do a random int, and then we're going to specify this between 100 megabytes to 500. And then we're going to do an else statement, and then we're going to do a traffic data dot append, and then MP. We're going to do the random function again, and then we're going to specify rand int. And this one's a little bit lower, so we're going to do 10 megabytes to 50. Awesome. All right, now just to walk through what we just did. So what we did was we create a timestamp. We add that into we added that in our array, and then anything that's specified between equals to 8 o'clock and to 6 p.m. we're going to specify, it's going to add some random between 100 to 500, and then anything else is going to be between 10 and 50 megabytes per traffic flow. All right, so now let's create our model. Because like before, we're going to use the linear regression, and then we're going to specify, like we did before, we're going to split it, and we're going to create a NumPy array. And then this is going to be, in this case, we're just going to do the timestamp, and then we're going to have to reshape it, right? Because this timestamp is a single array, so we're going to have to reshape this into a two-dimensional array. Okay. And then we're going to have to do the same thing. Well, we have to create a array for our megabytes for our traffic flow. So this will be for the traffic data. All right, awesome. And like before, we're gonna have to fit this model with our data. All right, now the model is fit. So now the next state we're going to do is we're going to add a few parameters and variables. So we're going to get the current hour. We're going to set the current hour to 1. Okay. In this case, we probably should do new to int. So if we're going to set this, we probably should do it correctly. Probably should do this too. Like this. No, I don't think this was. I'm gonna exit that out. We're not gonna do that. Make sure we exit that out. So, so we create our current hour. We set that to 1. We're also going to predict hours. We're going to predict, and we're going to set a list of hours we want to predict. So we're going to do predict hours. In this case, we're going to use 23. So we're going to predict 23 hours of the day. The next step, we're going to do a bandwidth. So we're going to do a link. So do a bandwidth. And we're going to set this to 500. So we have a link, bandwidth link of 500. All right. So now what we want to do is we want to create a while loop. So we're going to do a while loop. While true, and we're going to say current hour is greater than, is less than or equal to, and we're going to do predicted hour. Then we're going to run this code. Okay. So the first thing we're going to do is we're going to type in and get the next hour. So we got to say next hour, because we want to predict what's going to happen the next hour. So next hour is going to equal current hour plus 1. And then we want to do predicted traffic. Predicted traffic. And then we want to specify our model. And then we're going to do predict. And then we're going to pass in NumPy array. And we're going to pass in a 2-dimensional array of next hour. Awesome. Now, since we got that, let's specify our message that we want to put in our logging. So we're going to create a variable called message, and we're going to specify f string. And we're going to call this, I think I did this. We did predicted bandwidth, because we want to get the bandwidth percentage. Bandwidth utilization. And then we're going to specify what that's going to be. In this case, we're going to do, I think we got, so this will be predicted traffic. We're going to pull the first variable of that, and we want to divide that between the bandwidth, because we want to get the percentage. And then we also want to get out of that, so we want to times that by 100, and then we want to get a float of this. We're going to do 3, 4, and then we're going to put the percentage sign. So we got the predicted hour. Make sure I got this right. So we got this times that. Missing another one. This doesn't look right. So the bandwidth times this, and then the percentage sign. I think that should work. Nope, I had to. That's what I'm missing. And then we also want to. We want to put in the predicted network. So we do a predicted network traffic. Let's pull this up. Make sure you guys can see this traffic. For, in this case, it'll be the next hour. And then we want to next we want to give the actual predicted traffic value, and then we want to do another float, and then this will be in megabytes per second. I know that's long, so let's just double check this to make sure. So I have the predicted utilization, we're getting predicted traffic. We're getting that value divided by the bandwidth. And then we're going to times it by 100, so we won't have a decimal. We're going to put a float with a percentage sign, and then we're going to do the predicted traffic for the next hour. And then we want to specify the actual traffic in megabytes. Sweet. All right. Now with that, we want to get an if statement, and we want to do some play around with the logging. So let's just do predict traffic flow, and we're going to get 0, and we're going to say if it's greater than bandwidth, and then we're going to do times, and we're going to give it a percentage, so say 70%. So anything under 70%, we just want to do logging.info, and then we want to pass in our message. Okay, and then do an else if, and then we do predicted traffic is, in this case, will be greater than or equal to bandwidth 70, %, and then we're going to do predicted traffic 0 is less than 90. Let's do 90 bandwidth, 90%. And in this case, we're going to do logging.warning, and then the message will be message. Awesome. And then we need another else if predicted traffic flow is equal to or greater than, in this case, bandwidth times 0.9, which is 90%, and predicted traffic is less than bandwidth 1, which is 100%, and then we want to do logging, and then we're going to make this critical, and we're going to do message as well. Message. Awesome. And then we're going to do else. We're going to do catch all. If it doesn't match any of these, we're going to logging error, and then we're going to specify message. In this case, we're going to make this an F string because we want to say blocking, because if it's over 100%, it's definitely going to be some blocking or some queuing that will cause some issues with the site. So we're going to do prediction, and then we're going to pass in, the message. Awesome. And then what we have to do is we have to, at the bottom, we want to do current hour. So we have to increment this. So we'll do a current hour plus 1. And then we want to simulate this. So let's do a time sleep. In this case, we're going to sleep it for 3 seconds. And this is just to simulate an hour wait. Hour wait time. Sweet. All right, so let's walk through the code again. So we passing in the NumPy package, timing, logging. We're implementing our logging. So, best practice to log this stuff. So if you want to move it to a logging file, we can. We're creating two empty arrays, both timestamp and traffic data. We're getting the timestamps. We're incrementing a 24-hour period between the hours of 8 and 6 p.m. We're going to specify high random times between 100 and 500. We're going to do the same for the non-peak hours for 10 and 50. We're creating our model. We're injecting the X, and this reshape is converting the single array to a two-dimensional array. We've got our single for our y-axis for our traffic data, which is this right here. We're fitting the model. We're creating three variables, one for the current hour. We're setting it at 1. We're predicting 23 hours. And then also we're going to use a bandwidth of this particular link, or what we're monitoring is 500. And then we're creating a true state while loop. We're going to loop through while true and with the current value of the current hour is less than the predicted hour. And then it's going to remove that. So once it hits 24, it's just going to exit out. So we're going to get 23 hours prediction. The next hour is going to take the current hour, add 1. It's going to then inject the predicted traffic with the next hour. We implemented a standard message for all our messaging or logging. So anything that is under 70% is going to just give us info. Anything that's higher than 70 or at 70 or higher to 90 is going to implement a warning. And then anything that's higher than 90% to 100% is going to give us a critical, and anything over at 100% or higher is going to give us an error, and it says blocking. All right, so let's go ahead and save this. And with that, we can run this code. So let's go ahead and run it. Okay, so that's our first one. Okay, we're going to give us the info. It's pretty sweet. So we're going to run this to 23 hours. And then once it's done after 23 hours, it's going to error out. Well, it's going to stop. Sweet. All right. So now what we did was we simulated our traffic flow, but let's look and see if we lower the bandwidth. Say if the bandwidth is 150, see what happens. And really what I want to see if we get any warnings or any criticals. But what doing this gives us the ability to either increase or move traffic flow based off of the data or the machine learning AI that we have implemented to help us mitigate traffic flow, so we can minimize our pain points and our thresholds. So let's go ahead and run this again. Oh, let me clear this. Let's do a Control-C. Let's do a clear. And let's do the same thing. See what we get. All right, starting off the bat, we're in a warning, so it's good. Okay. Not good, but it's good that we're capturing that. So now with the critical, we could start working on trying to get and moving traffic. So that's a way where we can have triggers to say, hey, if it's operating at 90, let's start moving traffic. And now we're blocking. Awesome. So like I said, this is just a way where we could use the key benefits for networking and AI. We can leverage logging to specify a prediction of what a traffic flow might look like. And we have the ability to leverage this information to either move traffic or start shifting routes over. So with that being said, Thank you for joining, and until next time.